Freediving from theory to practice.
Freediving from theory to practice. Is it available on Amazon? Is it available as an ebook?
No, it's a problem because it's available from my university, but my university is closed because of COVID. You know? So I don't know how it works now, but maybe
now would have been
it will be good.
Now it would be a good time because everybody's got a lot of time to read.
Yeah.
Okay, so welcome, Frederic, and thank you for taking time to talk to us. So we've received a number of questions, but before we start, maybe you can provide a little bit of an introduction about yourself and about the studies that you do at the University of Rouen.
Okay, so I'm assistant professor of exercise physiology at the University of Rouen in France. I work on breastholding physiology since maybe 20 years now, and I practice this sport also, and I coach it also. So I try during my research to make the link between my coaching, my teaching, as a freediver too, and for my research. So,
wonderful.
Yeah.
Wonderful, thank you. So maybe we can just try to go through some of the questions that we've already received, and then we may be receiving questions during this session. So if you'd like to ask questions, please do. We'll put them in queue and hopefully be able to get to all of them. One of the questions that was asked, and I thought this was a great question, is one of the questions that I was wondering myself. And they were asking, they'd like to better understand the mechanism of increasing tolerance to CO2. And so does doing CO2 tables help, or is that the best way? How frequently should they be doing CO2 tables to get a permanent increase in tolerance of CO2? Do you have any thoughts about what is the best way to train and increase your tolerance in CO2?
Okay, a lot of things behind this question, in fact. Yes, it's important to understand that when you're breastholding, you are not hypercapnic alone or hypoxic alone. You always have the two gases, increasing or decreasing, because you consume oxygen and you produce carbon dioxide, okay? So this is the first thing. The hypercapnic table are for me a little bit strange because I test this table with gases, analysis gases with a specific device, and I found that this table are not hypercapnic at all. So it's funny to understand that hypercapnic training, hypoxic training are based on no scientific evidence. They are created by the past. In France, I proposed that, for example, several years ago, because I observed that if you train a lot with strong exercise at the beginning of the season, and if you continue until January, for example, your long apnea duration, your long static apnea decrease, in fact. So because it was not possible to make the relationship between intensity and heart rate, like for all exercise. You understand that? Yes.
Maybe you can expand on that a little bit.
So. When you do an exercise, your heart rate increases, and you have a linear relationship. So you can predict your intensity of training. But for freediving, it's not the same thing because your heart rate decreases, even if you do an exercise breastholding, if the exercise is not too strong. So is that why I proposed several years ago to forget usual training and to call that hypercapnic hypoxic training. But there was no proof about that, So this is the first thing that really important to understand. And second, for the carbon dioxide, you have to understand that carbon dioxide, for carbon dioxide, you have receptors. you know, peripheral receptors and central receptors in your body to detect variation of carbon dioxide. And the central receptors in your brain are very sensitive to carbon dioxide, whereas oxygen, it's rather the peripheral receptors. Is that why when you have a small variation of carbon dioxide detected by your brain, you have rapid adaptation, you know? And this sensitivity, its sensitivity to carbon dioxide, can be trained. So if you train breath holding, you train your receptors to move a little bit the threshold of your sensitivity to carbon dioxide.
Okay, so when you say that it's these receptors and you can train them, but if CO2 tables, the traditional CO2 tables is not the way to train them, what is the right way to train them? How do you reduce the sensitivity of your CO2?
Only by training, because there's a link between oxygen and carbon dioxide, always. And it's complicated because, for example, if you increase your carbon dioxide, it increases the cerebral blood flow to your brain, and you increase the oxygen for your brain, you know? So everything is linked. But if you consider all the mechanisms generally, you can increase your capacity to resist to carbon dioxide only by training. Even if you do long static apnea only, you will increase your tolerance to carbon dioxide.
And have you done any research specifically on, you know, what type of training is the most efficient in increasing CO2 tolerance or reducing sensitivity?
No, not on the type of training. There's not a lot of study on which kind of training is better to improve performance. But we test by the past, very good freedivers trained to hypercapnic training, you know, short distance, rapid, 50 meters several times. And we compare them to untrained freedivers. We found that their sensitivity to carbon dioxide were normal, not higher than control. Yes, and they were in the period where the training were really important. So it was a little bit surprising, but in fact, I think that the short variation of your sensitivity are still present. For example, if you train, you can move a little bit your sensitivity to carbon dioxide, but maybe it disappears in the long term, okay? Because we didn't find nothing.
So that's interesting. So that's almost contradictory. You're saying that,
yes.
You know, that these high performance, is it then just their ability, they're just as sensitive? Are they just able to tolerate it better? Or like, do you have a theory on why they can handle these long breath holds, you know, without going through the same struggle that beginning?
Yes, because breath holding performance is not only CO2 and oxygen. It's also lung volume, it's also relaxation, it's also your tolerance to stress. A lot of parameters are involved in the performance. So carbon dioxide is important, but lung volume is also very important. A recent publication shows that there's a performance mainly depend on lung volume capacity.
Interesting. Now, Alexei, I know that Alexei has a theory, and his idea was that he wasn't sure whether CO2 tolerance is the issue for longer breath holds and performance during longer breath holds. He kind of felt that it might be related to blood pressure, that as we are going through breath holds, our blood pressure is increasing, and our ability to be able to tolerate those blood pressure increases was kind of a better measure of our capacity to perform. Do you think that sounds right to you, wrong to you? Like, what's your thoughts on that?
It's right and false, in fact. Why?
Okay.
Because yes, it's true that, you know, we test expert freedivers who can hold their breath at least for 7 minutes. And we observe that we have two decreases in heart rate. The first decrease, and then in all of them, a second decrease around 50 to 60% of the performance. And at the moment of this second decrease, we have also the increase of blood pressure. It's simple, it's called the barrow reflex. You have the diving reflex, you have the barrow reflex, you have several reflexes in your body. And most of the time we consider the reflex separately, but there's relationship between each reflex. So yes, blood pressure increase, meaning that we are less efficient than marine mammal, for example, because in marine mammals, the blood pressure doesn't increase so much and is really stable, whatever the heart rate.
Interesting. Okay, great, thank you. So another area that people have been asking a couple of questions is on the question of diet. And so do you have any thoughts about alkaline diets, ketogenic diets, intermittent fasting? Like, what is an optimal diet for a freediver who's training?
Oh, the optimal. So there's alkaline diet, ketogenic diet, and fasted. There's some study on fasting there's two main studies on this topic that they found not the same result. In fact, the first study shows that because you're fast, you are going to use your lipid storage more. And if you use more lipids, you use more oxygen because it's more difficult to consume lipid. So you need more oxygen to burn fat. So if you use more oxygen, you are going to have less oxygen at the end of your breath holding. So one study shows that at the end of, yes? Hello, you have a question?
No, I think that was there was just sorry, that was just a technical issue. Okay, please continue.
Okay. So one study shows that at the end of a long static apnea, the people who were fasted have lower oxygen partial pressure in the blood. But another study found no difference. So it was the study of Lindon, then the study of Erika Chagaté, and they found opposite results. So it's a little bit difficult to understand if it's dangerous or not to be fasted from a metabolic point of view. From a mechanical point of view, it's more easy to have your stomach empty, because if you fill your stomach, it push your diaphragm, and then you will have less inspiratory volume. You understand?
Yeah, please continue.
So fasting is interesting because from a mechanical point of view, it can be efficient and you will feel more confident, more stable for your performance. After, alkaline diet is are known as a non-acidic diet and consists of fresh fruit, vegetable roots, nuts and legumes, and only a small amount of meat. But for this alkaline diet, you should know that there's no scientific evidence to support the claim of alkaline diet. It's interesting. The people for alkaline diet believe that they should consume food that corresponds to the balance of the blood, in fact. And they believe that diet rich in acidic foods disturb the blood balance and eventually lead to illness. This is the idea of such alkaline diet. But you know that your body has a complex mechanism to maintain the blood pH. You say pH in English? pH?
pH level, yeah.
Yeah, pH level. And even if your pH level is slightly alkaline, everything is done by your body automatically without doing nothing, without any specific diet, and your body do everything to maintain this pH acceptable, in fact. So there's no need to have alkaline diet.
Okay, great, good to know.
And
yeah, so
the last one, yes, the last
Sorry,
one
go ahead.
was ketogenic, no? Ketogenic diet.
That's right.
Yes, ketogenic is different. Ketogenic diet is a diet where you reduce your carbohydrate until 5% in your diet, and you increase a lot of fat until 80%, for example, and the other percent are the meat. But for freediving, there's no study on ketogenic diet for the moment, to my best of knowledge, showing that it can improve performance. What I can say is that on performance, it's really different because first, we react differently to such diet. We react differently using differently the fat after such diet. So it's highly variable and it's different. This difference depends on intensity of training, status of training, and how long your diet is. If it's 2 weeks or more than 3 weeks, it can be completely different. So it's difficult to say it's useful for freediving.
Okay, thank you, Frederic. Yeah, so I think some of the common wisdom that I've heard about diet has been, you know, for different types of disciplines, different approaches works better. Like for static, you know, fasting is great because it reduces your metabolism, and then it becomes easier because your metabolism is slower. But for, you know, the other disciplines, maybe not so much.
Yes.
Do you think that's fair?
Yes, I confirm. For static, fasting can be good, but for dynamic, you need energy. But most of the time, a lot of freedivers ask me, how can I eat? What is the best solution? But most of the time, yeah, and it's like for all sportsmen, they have bad diet. So they have bad general diet. So the aim first, before trying to change and to find the good performance, the first thing is first to have a good balance. And then when you have healthy food, a good balance between carbohydrate, protein, and fat, then you can adjust to the intensity of your training, but not the last part before the first part, you understand?
Fair point, fair point. So there's been another series of questions about diaphragmatic contractions, and I think it's been the subject matter of a little bit of discussion and controversy lately. For example, William Truebridge recently came up with a video where he said, that's just a complete misnomer. You know, it's actually the intercostal muscles are contracting. You know, the diaphragm the diaphragm can't move up. It can only move down. So there's no such thing as a diaphragmatic contraction where it's pushing the diaphragm up. Do you want to clarify the record on that? Is diaphragmatic contraction, is that a misnomer? Is there a more appropriate term to describe what we're experiencing in that stage of freediving?
Yes, I think it's not exactly diaphragmatic contraction. The problem is that the first study doesn't record by the past diaphragmatic contraction. We only put, I say we as physiologists, we put only electrode leads on the thorax, and we just show like that the movement of the thorax, okay? But it's not leads inside your skin to record exactly the diaphragmatic contraction. So yes, of course, when the diaphragm have a contraction, it's going down. So, and it's shorter. So it's create an intrathoracic depression so that your air can go inside. And when your diaphragm relax, it's up, there's relaxation. So the pressure increase and you exhale. So this is the mechanism of breathing, basic mechanism. But during freediving, you have involuntary movement, and the movement are rather involuntary breathing movement. You know, we should rather say that. But probably that the diaphragm movement and other muscle of your thorax participate to this situation, because when you breath holding, your diaphragm doesn't move. There's no movement, and it's not normal for your brain. So your brain sends input via the vagal nerve to contract it, and to the thorax to move everything. So saying there's absolutely no movement of the diaphragm, I don't know, because the diaphragm go up and go down. And when it goes down, there's contraction. So I'm not sure, but we can say it's involuntary, involuntary, is it? Yes?
Involuntary.
Involuntary breathing movement. Sorry for my English.
Oh, not at all. Your English is a million times better than my French. So thank you for doing this.
Thank you.
Okay, and so have you, in your training, coaching, have you found a secret silver bullet in pushing out or postponing the involuntary breathing contractions?
Oh, secret thing. Oh no, I found no secret thing. I just found that with training, the first contraction appear later, you know, and it's like for everyone, it's highly variable between each person. Some people have no contraction, even during long static apnea. I remember Stefan Lifsud have until 10 minutes, no contraction, but he feels the urge to breathe. So, and if you look at him, there's no contraction until the end almost. And other people have contraction very rapidly. So it depends mainly on your carbon dioxide sensitivity, but also it's a mechanical way. You know, there's two stimulation for this movement, chemical, carbon dioxide, and mechanical, the absence of movement. The absence of movement increase this mechanism, okay? And if you have absence of movement, at a moment, you will have movement, whatever the movement, diaphragm or thorax, that you will have. So the two mechanisms both increase your sensitivity to this movement.
Yeah, that's interesting. Yeah, do you have a like I think the common freediving wisdom is that it's all about relaxation. Like the longer you can, the deeper your relaxation or the ability to kind of get into a more relaxed state will mean that your contractions are postponed. Do you have any comment on that, or do you have any theory as to why some people after training can postpone it?
Yes, of course, relaxation is important, because if you relax, your brain will probably send less input to your diaphragm via the vagus nerve. So you probably will delay this mechanism, but you will have that by training, only by training, okay? Probably at the beginning, you have different sensitivity and you keep this difference of sensitivity, or maybe you increase difference in sensitivity and you increase your relaxation state. So you decrease input to your diaphragm and to your rib cage to be contracted.
Interesting. Okay, switching topics. So another area that we received some questions on is, of course, lung squeezes and trachea squeezes. One of the questions that was asked is that you know, if we do get lung squeezes or trachea squeezes, is there any permanent damage? Like, are we harming our body in a way that we can't recover from? Have you researched that, or do you have any findings on that?
Oh, yes. Squeeze, in fact, we call that squeeze in freediving, but it's a pulmonary edema, you know. It's important to understand the different kind of pulmonary edema. You have, in fact, two big families. Cardiogenic pulmonary edema, it's the cause of your pulmonary edema, it's a cardiac problem, okay? And you have also non-cardiogenic pulmonary edema. And most of the time, it's probably non-cardiogenic pulmonary edema for freedivers because of difference of pressure, that's all. But the mechanism of pulmonary edema, there's several causes for pulmonary edema. You could have hypoxia. It's well known at altitude. It's called high altitude pulmonary edema. You could have also pulmonary congestion by exercise outside of water. I'm not talking about breathholding. And you could have also pulmonary edema after swimming alone, okay? So in freediving, we have all. We have pressure, we have hypoxia, and we can have exercise, and we can have also cold that can create hemodynamic modification and then pulmonary edema. And also you can have additional factor that can be stress, bad equalization, and they are related, and diaphragmatic contraction too, because you increase diaphragmatic or not diaphragmatic, but you increase the pressure around your lungs, and it can increase the risk of pulmonary edema. And it's important to understand, for me, it's a point we discuss a lot with the medical board of IDA. For me, a pulmonary edema is, there's no small pulmonary edema or big pulmonary edema, they are all pulmonary edema because it concerns a vital organ, your lungs, you understand? So if at the moment you touch a vital organ, it's dangerous, okay? And the consequence of pulmonary edema are maybe rapid consequence, acute consequence will be a blackout because you have bad oxygenation at the end until the death, of course, if you do nothing. And the long-term effect will be probably to lose functional capacity of your lungs. But it concerns a lot of freedivers and it's underestimated for me. For example, there was a study showing that after a competition, 25% of the freedivers have acute respiratory syndrome, like coughing, hemoptysis, chest pain, or dyspnea. Dyspnea, it's bad ventilation, unusual ventilation. So yes, it's really important to understand that to prevent this pulmonary edema, you have to progress slowly. I know it's not the good, it's not fashion to say that, but you have to progress slowly, and because it takes time to adapt your body to pressure.
Well, that's certainly in keeping with the Molchanovs philosophy. So slow progress is definitely the order of the day for us. So thank you for confirming that.
Yes, you know, there was also one study, because I heard a lot that there was one study showing that you could have susceptibility, genetic susceptibility to pulmonary edema. It's probably true, but genetic susceptibility, it's only a small part of your problem. The bigger part is relaxation, equalization. Equalization is important, and diaphragmatic contraction related to relaxation, of course.
Now, so the common, I think, freediver wisdom is, hey, you know, lung squeezes are serious, trachea squeezers.
Hello.
Hello. Yeah. Are we having some technical issues? Your screen is frozen. Can you hear me? Can you hear me, Frederic? I think we might be having some technical issues, Elisa.
Yeah, it seems like. Let me check with. Okay, just a minute. I'll try to see what's happening.
Oh, I think he's going to try and dial back in here. Interesting stuff. Have you been able to get in touch with him on Facebook or WhatsApp?
No, he hasn't responded yet. So I think
wondering.
Trying
Internet
to
problems.
dial back in. Yeah, let's wait another few minutes, and if nothing happens, then he may be experiencing internet issues.
And from Jan Kaltz, he said that, oh, there he is.
There he is.
Hello, sorry. I have
No problem.
I don't know what's happened.
No problem. No
Okay.
problem. Okay, so sorry, we're in the middle of a question, and so the question is, or the common freediving wisdom is, hey, lung squeezes are serious, and when you you cough and it's pink and frothy, then yeah, that's a lung squeeze. You got to be careful of that. But trachea squeezes, nah, not so serious. You cough and it's very bright red, it's very streaky. That's not such a big deal. Hey, if you're gonna dive tomorrow, that's all right. Any correction on that? Thoughts on that? Like how does the common wisdom sit with you?
Yes, as I told you before, if you have an injury, it takes time to recover from this injury. You can imagine if you cut your skin, it takes 1 week, maybe. It depends on you, but it's inside. And it's your lungs. Your lungs just provide you oxygen. It's nothing, okay? But you can imagine if you have an injury inside, even if it's a small injury, it's a big deal, in fact, because it's supply your body for oxygen. And you have to understand that, for example, imagine your only one alveoli break. You have only one alveoli. And you have to understand that around this alveoli, there was a vasoconstriction to shrink this alveoli rapidly. And is that why rapidly you have no blood, you cause nothing. And you say, oh, it's finished. But no, it's not finished at all. This is just the beginning because your alveoli have, after inflammation, bad problem. And if you dive on this break alveoli, you will have more problems. Okay, so it can be dangerous. Is that why a lot of freedivers contact me to tell me how many times I need recovery? I say, oh, it's very simple. It's like for bronchitis, you need 3 months. Okay, if you have even a little bit of blood, you need 3 months if you want to dive later. And a lot of freedivers doesn't understand this thing, and they say, okay, I have no blood, I feel good. Okay, my saturation is maybe almost good. Sometimes it's lower, even without any symptoms. And they dive again, and they have another squeeze. And they have 2 weeks of rest, and they dive again, and they have another squeeze, etc. I found some freedivers have that like during 1 year, okay? And at the end, they stop freediving because they cannot, they doesn't understand how to do and what is the problem, the real problem. So yes, if you have a lung squeeze, stop freediving and have a long recovery. This is the only way.
And you wouldn't differentiate between a trachea squeeze or a, lung squeeze?
Yes, trachea squeeze. Yes, it's a little bit different trachea squeeze, but if you have a trachea squeeze, it means maybe you have bad equalization or you have also problem with pressure anyway. Okay, so because it's different to detect tracheal squeeze and lung squeeze, and sometimes freedivers say, oh no, don't worry, just a tracheal squeeze. They don't want to say they have a pulmonary edema. So for me, it's difficult to do the part between the two. You have just to discuss with the freediver to look if they feel pain here because they have a squeeze here, only here. Maybe it can be only a tracheal squeeze, but you cannot say there's no pulmonary edema too at the same moment. You cannot be sure, definitively.
Okay. So has there been any recent research on the long-term effects of freediving? I know that there was some research a while back that said these high-level freedivers experience some memory, issues and things like that. Can you give us the latest on the long-term effects?
For the brain, you want to know?
Sure, or in general, physiologically, is there issues or benefits for the long-term practice of freediving?
Oh yes, you have a lot of benefit because you resist to hypoxia, you have higher lung volume, you have also a good awareness of your breathing, and so you have a good heart rate variability, a good coherence between your breathing and your variability of your heart rate. So it's very good because it's decreased your cardiovascular risk, for example. But we found that elite breathhold divers have memory trouble. We compare, in fact, elite breathhold divers, less trained and control, and we found that in all elite breathhold divers, they have memory trouble. And this was related to the experience breathholding diving practice, and also related to the occurrence of blackout. So I'm not saying you are all going to have memory trouble, just saying that if you push your limit to blackout, and if you have a lot of blackouts regularly, probably you will have brain impairment, like in all the sports, in fact. Okay. Some of the study, for example, recently found that a protein increase after long static apnea, and this protein increase, it's called amyloid metabolism. Amyloid metabolism, it's accumulation of a protein in your brain in a disease such Alzheimer's disease, So it's linked always to memory trouble. And it shows that repeated long hypoxic situation can create this situation, and it's not normal. So even without blackout, if you do long static apnea, maybe in the long term we will see something.
Interesting.
We are going to build in France a study on this topic, trying to analyze with MRI and cognitive test with in Paris in the CEA with another neuroscientist. We wanted to analyze the freedivers to see if there's really the different structure impaired after long breathholding.
Interesting.
Training.
We'll look forward to hearing the results of that research. So a couple of other questions. One question was, is freediving appropriate exercise for overweight people or inappropriate for overweight people? Do you have any thoughts on that?
There's no research on specific exercise training for obesity problem and freediving problem. I think if you have obesity without hypertension or diabetes, yeah, you can dive. However, there's some links between hypoxic situation and obesity, because when you have a lot of fat, it's a hypoxic situation, and it's an inflammatory situation too. And we have a protocol with Australia to show, to test intermittent hypoxia on obesity. And we found that doing that with intermittent hypoxia, you decrease your glucose, your glycemia, and you decrease hypertension. In fact, because hypoxia upregulates glycemia pathway, for example. So it's a good way, maybe a good and novel mechanism to cure obesity as a complement.
Interesting. Okay. And a follow-on question is there a correlation between muscle mass and freediving performance?
Muscle mass and freediving performance, I don't know. Exactly, there's no study trying to test that. There's a study on marine mammal, on the body mass and the capacity to stay for a long period of time underwater. That's the mechanism involved in marine mammal are completely different. We test a lot of freedivers during the last World Championship in France, but we haven't yet analyzed all the results. But we test the muscular mass, and maybe we found something. Maybe, I don't know exactly, sorry.
No worries. Okay, and so there's another, I guess, recent trend has been kind of the rise of this hyperventilation practice that's been popularized by Wim Hof. Do you have any thoughts on that as it relates to a practice separate from freediving, and then as it relates to freediving itself?
Oh yes, you're talking about Wim Hof technique, Wim Hof method. Wim Hof method, in fact, is a method that already used by yogi since more than 1,000 years, in fact. He used breathing technique, all breathing technique, in a fashion way. So and sells this technique, saying it's his method. And this method is based on hyperventilation. But doing hyperventilation can be dangerous in freediving. Everyone knows that. And the problem is that he mixes, not a problem, but he mixes hyperventilation to resist to cold. And the link between the two are maybe interesting from a physiological point of view. But for freediving, I don't understand how it can be useful, because we try to avoid cold and we try to avoid hyperventilation. So I'm not sure that this technique will improve performance, and there's no evidence for that. Even if I know a lot of freedivers try to test this technique saying, oh, it's very good because I increase my mental to resist to cold. It's very good for me. Oh, maybe if you have mental problem, it's useful for you.
I see. Okay. Another question that came in was, is there a partial pressure of oxygen lower limit, that when we black out, like is there been research done on kind of the boundaries of partial pressure of oxygen and blackout? Does it vary per individual? Is it trainable? Like, what are your thoughts on that?
Yes, it's like for carbon dioxide. You can train your ability to resist to low oxygen partial pressure. And it has been found in a study we did, and recently there's another study of Italian team. They test in the Y40, the swimming pool to 40. They test freedivers after a dive, and they found that at the end of the dive, the partial pressure of oxygen was lower, without any signal of blackout, any sign. But yes, you can have a low level of oxygen. It's possible after long static apnea, after dive. And it can be trainable. You can train this adaptation, because when we test the freedivers for carbon dioxide, we test them also for oxygen. And we found that they had very good sensitivity, good reaction to low oxygen level. So yes, it's trainable. And you have just to have a good planification of your training if you want to have that.
Okay, great. Kind of in a different area, someone was asking, what does it mean for what does it mean your hormonal regulation changes as it relates to short-term adaptation? What is that like, and what is causing that change in your hormonal regulation related to short-term adaptation? Does that question make sense, or?
Not really. I don't understand the question. You want to know which kind of hormonal changes you have diving?
Related, yeah. So, well, in short-term adaptation related to hormonal regulation. Is that a subject?
Yes, I suppose. So yes, there's few studies on hormonal changes after or before freediver, 2 or 3 studies, I remember. They show that there's few changes. There's some changes related to endocrine status of men. And the changes come from, you have the axis, it's called hypothalamo-pituitary gonadal axis. It's come from your brain, you have the axis, and this axis produce several hormones that can regulate many things in your body. And a study shows that after breastholding, there's sometimes some increase of some gonadotrophin hormone and some adrenergic system. So it's increased a little bit your testosterone level, but it was not really significant. So there's not a lot of things, but there's study rather from a hormonal point of view, showing differences between men and women, but it's a little bit different. Another question, I suppose. And they show, for example, that the breastholding time between men and women were similar, whereas the physical capacity, the lung volumes, and the hemoglobin concentration were higher in men. And recently, it's a study published this year. It's a Greece team, I remember, and they show that the menstrual cycle, there's different phases in the menstrual cycle, luteal phase and other phases, and they saw that luteal phases, if you do a static apnea in the luteal phases, it's increased a little bit the apnea duration. So probably that estrogen and progesterone, the hormone of female, increase and have an impact on ventilation and autonomic cardiac regulation too.
Fascinating, interesting. Okay, well, last question. What do you think is the newest and most exciting research that's being done on freediving right now? Has there been some particular study in the last little while, in the last year, that you found was really kind of mind-blowing with respect to the research that was done on freediving? Is there anything that stands out for you?
Yes, there's different research interesting for me, but they are not really specific to freediving. For example, there's a beautiful study on the effect of preterm birth on oxidative stress response to hypoxic exercise, for example. And they show that full-term born adults, for example, increase their oxidative stress, whereas after an exercise in normoxia, acute exercise in normoxia, whereas preterm born adults have not. They have a decrease of oxidative stress. So it's interesting to show that there's a long-term consequence of oxygen environment since you're born, since the delivery, you know, and the consequence may be still present, for example, in freediver. I don't know, nobody tests that in freediver. Nobody knows if we have a lot of preterm adults or not. Maybe we should do that to see if we found a difference.
Interesting. Okay, well, I think we're almost out of time here. But really appreciate your time. That was fantastic. I think I'm sure our audience really appreciated your thoughts and knowledge. Is there any other question that's coming up? Oops. Yeah. So I think why don't we wrap that up there? I'm sure if you have any additional questions, please send them to us, and we'll see if we can get some of Frédéric's time to answer some follow-on questions. But yeah, thank you so much, Frédéric, for coming on,
for your invitation,
and sharing with us. And for those who are interested, Frédéric's book is he has a book that's coming out in English. Unfortunately, you can't get it right now because the university is closed. But after this COVID situation settles down, I'm sure there's going to be lots of people who are going to be interested in getting a copy of that.
Yeah, thank you.
Okay, so thank you very much, Frédéric. Thank you, Lisa, for being our technical support. And
thank you, Chris, for the great moderation, and thank you for participating to everyone. Bye.
Thank you, Lisa. Bye.